are actually pretty sticky. But when the blood vessel is whole and it has not been broken, we have to make sure blood flows without sticking. In an unbroken blood vessel, it is lined or coated with something called prostacyclin that repels the platelets so that blood flows freely. However, when that vessel gets broken and the collagen fibers get exposed, I now have created a situation where my elements, these formed elements, can stick. So my little platelets that are moving through the blood, they begin to attach to the collagen fibers. They begin to create a plug, and look what it begins to do. It begins to stop the blood flow. This is now, from this platelet plug, it's going to allow for all of the help that got called in when that vessel broke. The white blood cells, clotting factors, all of the help to come in and do its job. So that platelet plug, it'll begin to break down, release chemicals. It releases chemicals to start the process of healing and clotting the blood and stopping the blood flow. Continue to support vasoconstriction so that we can have the rest of the process take place.
Is this prostacyclin thing the way the body prevents inappropriate blood clotting?
Hold on to that thought, because these chemicals, we have to make sure that these chemicals and these processes that are taking place do not lead to inappropriate clotting. So, this thromboxane A2, people who may have a clotting issue with their blood, they might take an aspirin every day. Guess what it interferes with? Thromboxane. And therefore keeps the blood thin, because this would interrupt the process and clotting would not be able to occur. Does that make sense? Other ones are simply, we have now started a positive feedback cycle. Positive feedback feeds the process. It makes the process continue. If you do not break the cycle, it ends up in being death to the organism. This means at the beginning, blood clotting is effective. But if the positive feedback cycle is not disrupted, the organism will die. Yes. So the second mechanism, come in, create the platelet plug, call in some other chemicals, and let's get to the third, coagulation. This is my actual clot. It's important that blood clotting does not clot under normal conditions, which is what Talon just asked about. I'm going to show you how the body keeps that from happening. But at the time of the breach, yes, I need it to occur. This process as a whole involves over 30 chemicals. Yeah, every time you do something as simple as that paper cut, this is what's taking place. And all of this stuff takes place. All of these chemicals get called up. All the clotting factors get into everything. That's how important your body thinks that stopping that breach is. The overall objective: convert the fibrinogen, that little protein flying around and moving around in the blood, into fibrin. Let's get the process going so that I can create healing for this breach. This is going to take place whether it is a breach to the outside environment or whether there has been an injury internally. The process as a whole, we say, has two pathways, either intrinsic or extrinsic. For the process of coagulation, the blood clotting, basically extrinsic. What is happening outside of the blood, meaning outside of that blood vessel. So extrinsic, I need my clotting factors, but that has to come from information that got released when the vessel was injured. And that is dependent on perivascular tissue, the tissue right there around a blood vessel. So they consider this an extrinsic mechanism. Intrinsic, basically all of these processes occurring in the blood in the vessel itself. Their goal: work to achieve hemostasis. So, let me think here for a second. Check out this picture. What you think? Every single time they're showing the image up there at the very top of what looks like a splinter going into the skin. Y'all ever had that happen? Anybody in here never had a splinter? This is the process that had to take place so that that little teeny tiny area, and that's all I'm talking about right now, didn't become something that killed you. Now think about this in relationship to other injuries we could get. Not something that's going to create hemorrhaging, okay? That requires extra help. But the process still is taking place. It just can't meet the demands of the blood loss. That's the problem with hemorrhaging. Even though we get the process of creating all the chemicals, bring in the platelets, try to create a plug, all that sort of stuff, it's not that it's not occurring, it's just it's not enough. Because the hemorrhage is flowing out the blood too quickly, which means along with it, all the chemicals that are needed and the component parts. So let me look at this. In the extrinsic, outside of that blood vessel. I damaged my body in some way. So that means I went through tissues that are around the blood vessel, the ones that are perivascular. Well, guess what? They'll go into motion too. Now, I got a factor, I got a factor. Factor 3, factor 7. I'm not going to ask you to know all of these. Okay? I just want you to recognize there's a common factor for both of these pathways to function and get the overall result of healing. Over here, when I broke that blood vessel was intrinsic. 1, 2, 3. Got some other stuff going on here. What do you see? Calcium. Calcium is needed for blood clotting to occur correctly. Therefore, another reason, maintaining the calcium levels within your body. So calcium becomes very important in this overall process. Once my extrinsic is in motion, my intrinsic is in motion, I still have not gotten to the point of the clot. What is it that each one, what factor do they have to get to stop the bleeding, for it to begin to form the clot? What line is each one getting to? Factor what?
Factor 1.
Factor 10, factor X. Because factor X should be inactive until the process starts. My goal in this entire process, activate fibrinogen. This does not happen if either one of these processes does not occur properly. Brian?
Where's the phosphorus trifluoride coming from?
That's going to be coming from the blood also. And that would be something that is getting recognized when all of these chemical signals are sent out. Remember, it's over 30 signals. Over 30 chemicals required for the clotting of the blood. When the platelets secrete their sort of like their call out to the chemicals, this is one of them that'll be called up.
Cool. We kind of went over where the calcium ion is coming from, but we never really mentioned it.
Now remember, when we take in chemicals through the blood, through our foodstuffs, okay, our salts contain more than just like sodium, magnesium, and so forth. And we're going to see that like chlorine and so on and so forth, these would all be dependent on the electrolytes of the body. So, if I can activate factor 10, what did I get to activate? Prothrombin. What did I just say on one of the previous slides? Platelets are dependent, or they are termed thrombo, because they get to deal with this from the liver. Do you guys remember me talking about that? So now that calls up the liver. I get my thrombin. Thrombin comes in. I activate my fibrinogen. Fibrinogen gives me my fibers. Fibers create a net that begins to trap